Okay, in this video I'm going to be explaining how does a synthetic file system work. Firstly, I'm going to go over again what are synthetic file systems. A synthetic file system is essentially a file system that doesn't exist on a physical disk in the way traditional file systems do. Instead, it's created and managed by software and might exist entirely in memory or be generated on the fly as it's accessed. So how does a synthetic file system work? When a program like Google Chrome accesses a synthetic file in a synthetic file system, this is what's happening. In this example, we are going to be using proc/CPU info for example. 1. Google Chrome makes a specific system call to the kernel asking for the data of proc CPU info. The kernel gets the call and queries the VFS to figure out what code handles that file. The kernel then reads the title proc/CPU info and goes, hey, I know what that is, and the kernel then produces the data of the CPU proc/CPU info and gives it to Google Chrome. So, here are 3 takeaways from synthetic file systems. Not physical. Unlike traditional file systems, synthetic ones do not store data on a hard drive or SSD in a persistent way. Generated on demand. The files and data in a synthetic file system are generated on the fly when they are accessed. This means that the data might be created, modified, or fetched by the software whenever you try to access it. 3. Dynamic content. The content can change dynamically based on various factors such as user input, system status, and other variables. Use cases. Synthetic file systems are often used for system management, providing information about a system. For example, in Linux, the proc file system is synthetic and provides information about running processes and system statuses. So in a way, a synthetic file is less of a file and almost more of a script for the kernel to follow to make certain information on a program request. But the program is asking for access, asking for access to the file. But the program that is asking for access to the file doesn't know the difference and thinks it's just a file. Okay. So, what are examples of synthetic file systems? Consider a synthetic file system that provides information about the weather. There might be a file called currenttemperature.txt. When you open this file, the system doesn't just retrieve the pre-stored data. Instead, it might reach out to a weather API and get the current temperature, and then display that to you as the contents of the file. The actual temperature data is never stored in traditional sense, but was generated and presented dynamically when you tried to access it. Why use synthetic file systems? 1. Efficiency. It can be more efficient for providing dynamic system level information without using disk space. 2. Flexibility. Developers can create a structured way, like files and folders, to access dynamic programmatically generated data. Simplicity for users. It allows users to interact with data using familiar file and directory structures, even though the underlying data is generated on the fly. In essence, a synthetic file system is like a dynamic virtual representation of files and directories where the actual data might be generated or fetched by software in real time, rather than being stored persistently on physical storage. So there you go. That is how a synthetic file system works.